Hello and welcome back to the Oxford MAT Livestream. My name's James, we're back from our summer break and it's time for 6 livestream episodes looking at past papers from the MAT. Great to have you with us. If you're joining live, I think you can join in Slido in the usual place, which is I believe slido.com, and enter the event code MATLIVE, or if you're on the MAT Live homepage, which is here on the screen or down there in the YouTube description, there's a button you can click on to join chat. If you do that, you could be like an anonymous person or Jacob in chat who say hello and good afternoon, and they're joined by Callie. Callie is a third-year maths student at Oxford who is doing helpful things like moderating chat and also maybe occasionally reply to things. Say hello, Callie, as well. Good, right, okay. I like to start with the how's your day going poll, so I'm going to switch that on, I think. But hello as well to another anonymous person who's just joined. It's a good reminder that you can be anonymous over there, can't you? Right, there's the how's your day poll. Yes, thank you, Callie, running chat. Good. Quick reminder while that's happening. Oh, look, did you see those 3 all at once? Across the board. While that's happening, a quick reminder to everyone that test booking for the maths submissions test is open, so you can register to make an account and also book at a test centre. If you're having trouble with this, there is a contact option in the test registration portal, and that's the best way to get a response from the Oxford team in charge of booking, not just for the MAT, but for all of the tests, so they're across multiple tests. If you message me on Slido or something, then I will just try and point you to that team. I hope you're not having problems. I hope that's going well. If you're watching this in the future, then the deadline for booking the test is very soon from my point of view. If you're watching this in 2025, then please go and check that website for booking. If you're watching in a future year, then please do check that website or a similar website to see what's going on with Oxford tests in the future, because this video is live in 2025, but will live on the internet for goodness knows how long this will live on the internet for. I'm going off on a tangent. How's everyone doing? Everyone's doing pretty well, actually. Oh no, 3.9. Why is that 3.9? It doesn't look like 3.9. It looks quite good on the graph, but then you read the number as 3.9, which is not that amazing. Okay, I guess I'm sorry we're at a 3.9. I'm going to try and get that up a little bit, I think. And 3% of people are having a 1-star day, which is really terrible. No, thank you. Somebody voted 5, just what I was saying. Stop that there. Top question. Can you do the MAT for fun? So you can only do the MAT if you're applying to Oxford. It is up to you whether you have fun or not, or well, maybe not. But you can't do MAT unless you're applying for maths or computer science or joint honours at Oxford. You used to be able to do it if you were applying for, of course, these are other universities, but it's just Oxford these days. Hello, anyone else? Joe was at a summer school, missed some summer things, but now we're back. We're here. We have got, slightly ambitiously, I have drag-dropped 3 past papers. Chat is, you were still there in my heart and on my screen, but you are not on that broadcast. Ambitiously, I've got 3 past papers on the Miro board. This is quite exciting to me. I can sort of zoom in on questions you see and zoom all the way back out again. My plan for this, I think, is that I would like to pick my choice first of a short question to show you from a past paper, working one by one, and then maybe some democracy. We might vote for a question to do. Maybe we'll take it in turns. I would recommend that people have done the questions beforehand or had a look at the questions beforehand. So this is your cue if you haven't looked at 2007, 2008, 2009 past papers. We're going to do those one by one, but this video contains spoilers. We've got answers to MAT questions in here. So if you haven't seen these questions yet, then lots of the benefit of being stuck on these questions will be ruined for you if you watch through and see the answers. That's right, it's a YouTube video which tells you not to watch it right at the start. Here we go. Okay, 2007. Hey to the person in chat who says hey. When applying also for funding, applying for a scholarship, what criteria to select? I cannot remember what the criteria are. Choose whichever one is closest to the truth of your plan. And that is a question about future plans. So choose whichever one is closest. How much revision? I don't know. I'm really terrible. Somebody wants to know how much revision should I do, and I don't want to go down that rabbit hole. I want to do some revision now. Here we go. So I've picked up this question as one that I would like to talk about. Here it is. It's got integral signs in. This is a short question. And it's got 4 integral signs in. My goodness, maybe we have to do 4 integrals. Wait, 5. I've just spotted this one over here. But then you look closer and you realise that there are 5 integrals on the question and you can't do any of them. Nothing personal, but you haven't been told what the function f of x is. It's quite funny actually. It says given, but we aren't given a particular function f of x. We're told some facts about what would happen if we integrated various things. And I think what I'd quite like to do, if I had budget for research and ethics approval to do research on people, would be to show math students this question and see where your eyes go. Where do you look when you see this question? For me, I kind of think I bounce around the f's to check that there's f in all of these integrals. And it was only later that I noticed that the limits are not the same. It took me ages to notice that. Maybe I should have spotted that earlier. I suppose I'm looking backwards and forwards to notice that this one and this one are the same. So this is the thing that I want. Interestingly, you can find it right there in the question. And we're going to find the value of that one. Yeah, limits. Nice. If you leave and do the paper and come back tomorrow, the video will be here. The video is recorded. If you would like the ability to request which question we're doing, then well, you can try and get ahead of me, or maybe see you next week for live and participation. This is mainly just a walkthrough of papers, but with some chat with live people who are here live. And someone says I'm tempted to just do the papers, so go for it. I think some people are doing both, so maybe you're playing along at home, or maybe you've already played along at home. My chat. Yeah, so someone in chat says hidden simultaneous equations, and it is a bit hidden, I suppose, but if you really squint, then we've got blob over here, something over here, another thing over here, and then a 4th thing down here. Thing plus thing is 7, thing plus thing is 1. We've got these different objects. Because for simultaneous equations, I would quite like 2 unknowns if I've got 2 equations. So what are the unknowns? All 4 of these are different. So spotting in chat, thank you, spotting that you can compare limits is a good idea. And I guess I'm doing this because I know that I want this one, and I don't really want this one, or I'm puzzled by this one over here. But maybe after thinking about what it means to integrate from 0 to 2, I've got this idea in my head that we're talking about an area maybe. The integral from 0 to 2 means all of this area under the graph, if it's like that, and that would be integral from 0 to 1 plus the integral from 0 to 2. So a key idea that's not printed in the question and might or might not be in your revision notes anywhere. Or what do I mean revision notes? I mean it's not in the MAT Livestream revision guide, right? Or the A-level revision notes, I suppose, maybe. Depends a bit. The integral from 0 to 2 is the same thing as the integral from 0 to 1 plus the integral from 1 to 2 of a function. Okay, that's one idea. And then second idea, probably we can move numbers outside the integral. So if you triple the function, you get 3 times the area. So you always have an option to move a scalar outside the front. Oh, excuse me, moving a scalar outside. Yeah, so I just said a very strange phrase, and you're right to call me out for it on chat. I said MAT Livestream revision notes. That's me being rusty. I mean the worksheets that we had for the previous live streams. Sorry, on that website, right? The things we've been doing on the live stream before we got to class papers. I don't know why I called it MAT Livestream revision notes. I suppose there are revision notes inside the worksheets, so I'm not completely off base, but well, okay. Okay, so I've got to move constants at the front, and I think my unknowns are this first integral and that second integral, and then I'm pretty close, aren't I? This thing over here is the sum of those two. So if I call these A and B for my two unknowns, then I've got 3A plus 2B is 7. That was quite straightforward. And down here, I've got A plus B plus another B. Yes, another B is 1. It's quite good then, isn't it? What do I want? I want A plus B. I want both of these. Then maybe I should have given this a single name rather than calling it A plus B, you know, the thing I want. Maybe that would have been tidier, but I'm happy now. This is turning into equations that we can solve. Good. Yeah, it's been quiet today. I think that's nice. Someone in chat, let's switch that on. That's exciting. They've got their own shorthand for this, which is fair enough. So theirs is 3 square bracket 0 to 1 plus 2 square brackets 1 to 2, which, fair enough. Is it okay to use the shorthand, is the question in chat. To which I suppose the answer is, for this, yes, this is multiple choice question, you can do whatever you like. But more seriously, if you're inventing shorthand like this, and you want somebody else to understand it, for sure, then what you need to do is just briefly say what it means. It's surprisingly hard to guess what people mean by shorthand. I'm guilty of this, I know, of just writing down a list of numbers and trying to remember that I mean the translations of the graph that I would do if oh my goodness, whatever. If I want somebody else to understand that, maybe because I want them to give me marks, then I need to include a sentence to say, here's what that means. Where means, and if I really think about it, then this is general notation, isn't it? So you want A to B or something. F of x dx. So yes. And in chat, somebody else wants to call them I1 and I2, where the 1s and 2s are subscripts. Yeah, so again, this is a bit like my big A and big B. If I really want to make sure someone's following, it's under chat now, isn't it? If I really want to make sure someone's following, I'd probably write out let A be 0 to 1. So if I was writing up a solution for the website or something where people might look at it and I really want them to understand what I'm doing, then I'm probably going to write something like this. And your choice of what you're going to write there, what you call them, doesn't matter. But if we're talking about explaining your maths, then, well, it's not obvious if you just call them I1 and I2, because I think the natural thing for I1 and I2 to mean would be 0 to 1 and 0 to 2. I don't know, maybe? Maybe not. It's hard to guess, right? That's what I might guess if you don't tell me. And then I'm confused because that doesn't match. Good, okay. Sound cutting out possibly for some people, not others. That's a sort of terrifying thing for me to read because I think it's fine at my end. Okay, good. Right, I stopped shy of actually getting a number on this, didn't I? I should go and solve these. How do I feel about solving these? I'll take the difference. 2a is 6, so a is 3, b is -1. So then add them together and get 2. I think I get 2 at the end. I haven't decided how excited I am about getting correct answers in this live stream. Good, okay. I just wanted to zoom in on this one because I thought it's a fun combination of facts about integration and simultaneous equations. A style of question that I really like in past MAT papers is ones that mash up two bits of the syllabus. When we went through the worksheets, we looked at topics separately. But even there, maybe you noticed along the way that it's quite hard to put certain MAT questions into particular boxes and say, this is definitely a geometry question, that one's definitely an algebra question. You might have noticed along the way that we had a whole session on polynomials and lots of the questions used other bits of maths because some of the best ones combine things together. Right, this is 2007 at the moment, so that's pretty good. Yes, we should absolutely subtract those two equations. Good idea, Joe. Yeah, so this is from the olden days when MAT multiple choice questions only had 4 options. I think it was about 2014 that we switched to having 5 options. We're looking at old papers today, back in 2007. Historical note, I mean, look at the front page. It's all different. It's the colleges of Oxford University. It's applying for, and it lists all of these courses. But we've changed what courses. This is not the current list of courses that. Anyway, computer science and philosophy is not on the list. Maths and stats. Anyway, several things have changed since 2007. But one thing that's not changed is how much I like integration and simultaneous equations. So I also circled J. I sort of think there should be maybe a bit of a vote happening in a second. Let's do a vote in a second. People in chat saying it's from before they were born, which obviously terrifies me, but here we are. Great username as well. Good job, Matt. What should be your first approach for integration questions? Kind of a bit of everything, isn't it? You've got so many things you know about integration that I can't really tell you that there's one thing you should check first, because there's so many things you know. I would look at the thing inside the integral and decide whether or not I can integrate it, which sounds stupid. But in this question, my first thought is I should do all 4 integrals, and then my second thought is I really can't. So maybe that's the first thing to think about. Can you literally do this integral? There's a long question. I'm sorry to zoom in and out so much, but there's a long question on this paper, which I'm probably not going to talk about, where you see this integral, and first thing that I would think is, can I do this integral? And yes, it's a polynomial in there. And then I read the question that says without explicitly calculating it, and then it says calculate it. So I'm going to do this integral, and my temptation is to just, maybe on a scrap of paper or the back of the booklet or something, is to do the integral straight away. And now there's no mystery, right? There's no integral sign anymore. There's just some quadratic in C. So I think I'm going to be fine with this question because I've solved the mystery. It's not really anything to do with integration. It's a quadratic. Anyway, never mind. Just a thought. Timing is hard, especially because in 2025 you have quite a lot of multiple choice questions. There are 25 of them. I would try to spend I think I would spend 2025. I think I would spend an hour on the long questions and an hour and a half on the multiple choice questions, but that's not a rule. That's more of a guideline, and you're free to absolutely ignore me, especially if you've done some questions and think that your personal timing is different from that. Right, people are telling me their birthdays. Right, okay, let's do the vote. I think I'm going to do the vote. This will go well, won't it? There you go. So it's a vote. I think it's set to multiple. Is it multiple? Yes, you can vote for as many of these as you like for things you want to do. I was about to do question 1J. I am now doing a sort of democratic approach to find out if that's what chat actually wants. I'm going to put it on the screen just so that we've got some maths on the screen at all times. And I'm going to quickly think about what I'm doing. What am I doing? I'm streaming. Is it going all right? Yes. Good. Voting's in progress. This question's a little bit weird. We've done some of these. I think we used to do more of this style where the question has lots of weird elements that you need to sort of look past. Well, there's lots of wrong things you could think about, I suppose, like actually trying to add the things here. It's a bit like my integration intuition, where with integration I try and say, could I do this integral? Well, the answer might be no. And when I see this big sum, I sort of think, I can see a general pattern here that they're trying to go for. Square numbers up here. Can I add together n to the k squared across different values of k? No, I have no idea how to add that. I can add 1 plus 2 plus 3. I'm all right with the constant numbers, but not all of these powers of n. I don't know how to add those together at all. Yeah, that's nothing like anything I could do. It's not geometric series or something like that. Because the powers aren't in a... if the powers were a linear sequence, sorry, if the exponents were a linear sequence, then it would be a sort of geometric progression question. We've done one of those before in the sequences and series live stream, where it's sort of L squared, L cubed, L to the 4, and you're asked to multiply them together, and that's fine. Yeah, so then the way you do this question is very weird, which is you just plug in n equals 1, which I think is odd. you just plug in n equals 1, that's good enough. So this is currently winning the vote, so I will carry on talking about it, and then I think we're going to G and I. We'll see. Yeah, thank you people in chat who are joining in. I just got another vote for this, so then G and I next. I'm going to grab my green pen and write down G and I. Okay, doing well in the poll. Good. Okay, thank you for voting. What else is going on? Yeah, so chat is summing this up very nicely, thank you. Yeah, okay, fine. I said 1 was odd, good. If it's true for n equals 1, then it's true for all n. That way around is not super obvious, but you have to realise that the left-hand side gets larger the larger you make n. So true for n equals 1 if this, then true for all n, because and then I'm going to write LHS to mean the left-hand side increases. It's an increasing function of n. Quite a mad one, right? Like it grows really quickly, but if you make n larger, then all of these terms get larger. So if you put n equals 2 in here, then 2 is larger than 1, 2 to the 4 is larger than 1 to the 4, 2 to the 9, my goodness, that's larger than 1 to the 9, and then so on if you replace 2 with 3 or something. And also, and this way around it's silly, if it's true for all n, I mean greater than or equal to 1, don't I? Let's put my little, sorry, let's get that right. Oh, back up. When I say all n, I mean all n in the question, greater than or equal to 1. Okay, here we go, the other way around. If it's true for all n greater than or equal to 1, then it's true, spelling true, for n equals 1. And that way around is just because 1 is greater than or equal to 1, which is a little bit daft. So both ways around are true, that you can replace the n greater than or equal to 1 in the question with n equals 1, like this. And then you've just got a straightforward inequality. Because if you plug in n equals 1, then you just have some inequality involving k and some huge number. And it turns out to be this huge number. But I just think that's a bit weird. That you have to realise that all of these powers, which are so huge, the only relevant thing is that they're increasing functions. So it's sufficient and necessary that it works when n is 1. See, that's super weird. People know about sum of natural numbers, 5050, and then plus 100 more. I like that. So you have a sum that you feel strongly about adding these 1 to 100, and then you've also got 100 of these terms that involve n, but if you plug in 1, each of them is 1. Is there any other way to solve this? I don't know. I don't quite know what that would mean. Surely your proof has to... Yeah, it's not enough to check values at other values, values of the left-hand side at other values of n, because it is necessary that this holds for n equals 1. So if your proof is more complicated and checks more values, then you will eventually have to check n equals 1. You want it to be true in the question here for all n greater than or equal to 1. So I think that you have to plug in n equals 1 at some point just to find out what's going on in that special case. And then the fact that that special case is good enough means we're done. Yeah, sort of think you're going to have to do that. Hello Anonymous, who's asked about gap year applications. Yes, you can apply while you're on a gap year. If you, the standard advice about deferred entry applies, where we've got some advice about gap years. We like it if people have planned some mathematical activities. If you're currently at another UK university, then our policy is that you can only apply in exceptional circumstances. So I think you're saying gap year to mean that you're not at university. Oh, how do we actually calculate the sum? It's an arithmetic progression, because it's 2 plus 3 plus 4 for n equals 1. I mean, in general, for n equals 2, I have no idea how you would calculate this sum. But for n equals 1, it's a geometric progression. Or said differently, I think someone in chat separated out all the n terms separately from all of the plus number terms. So for them it's 1 plus 1 plus 1 plus 2 plus 1 plus 3, and then they did sort of these bits, because I think that's a sum you might know. It's that story about Gauss. It's the sum that allegedly Gauss does as a small child. Gauss is told to add up the numbers from 1 to 100 inclusive, add all of them together. That's 100 things to add, that'll take ages, but no, that's the one that child Gauss says, 5050. So if you've heard that anecdote, then maybe you know that that bit is 5050 plus and then 100 more. So you're kind of primed to recognise fives as being something like that. Will I be able to change my admissions exam account to another maths course which also needs to map after registration closes? I think you'll find. I think the important thing is that you register for the test. If we're going to try and match all the registrations to Oxford applications, because you can only take the test if you apply for Oxford, we will notice if courses don't match up, but there's so much else that we can match on, like name and UCAS number, and I think it's going to be absolutely fine. The important thing is you apply on UCAS for the course that you want to do, and that you register to take the MAT, if the MAT is the right exam. You know, if you're here because you're applying for physics, then changing your admissions math, yeah, you say another math course, you're going to be fine. I told the Gauss story as if it's a myth. I've got no idea. I don't know how I would prove or verify it. It feels like a myth, doesn't it? It's got the kind of structure of a myth. You know, young child does this big sum, but it's also kind of believable. Like, children are always doing big sums, and being good at sums is something I know that Gauss was. So it has the structure of a story, though, doesn't it? Do you think the AI? I don't know about the AI Olympiad. It's up to you to explain what that is and why that's useful for you as you're getting ready for university. Sounds right. Congratulations on winning the AI Olympiad. I'm surprised there's a new one I haven't heard of, but there you go. Why is k not less than or equal to 5.58? Well, the inequality we were looking at was true for all n, so it's got to be true when n equals 1. And if you plug in n equals 1, then you just discover this fact that in order for that to be true, k must be less than some particular number, the number that the left-hand side is when n is 1. It's got to be less than lots of things. It's got to be less than this whole sequence of numbers for different values of n, but that sequence starts at 5150 and goes up. And the only way you can be less than all of these numbers is if you're less than the smallest one, which is the first one, which is the one we were calculating, which is 5150. So k has got to be smaller than lots of things, but we know what order the things are in, and we know the first one. We'll be fine. Okay, people voted for G, which is this, and I should warn you that this question is in radians. We talked about this in our past paper guidance video, which maybe not everyone joined for because it was in the summer. Some of the old questions are written in terms of radians. I know that some of you like radians, and some of you haven't met radians. So for some of these, you might like to skip things with angles if you don't care for radians at all. They're not too bad though, right? You know roughly what sine does, and sine squared. It's measured in a different unit, so the axis is labelled strangely. I suppose it's interesting that it's the same x up here as it is x inside the trigonometry, but you can have a go at this question in degrees if you like. Okay, so this one is about the shape of functions, right? So it's 2 to the minus x. We know what that looks like. Oh, not like that. It doesn't cross the axis, does it? That's kind of important. Spoilers, that's greater than 0. And sine squared, we know what that looks like. Although I notice it's not quite sine squared, is it? That's not a great picture of sine squared, but I think I'm going to get away with it. It's sine squared of x squared. So I know I'm looking for something that decays as x gets larger, because sine squared is bounded. It's between 0 and 1. It's not going to do anything surprisingly large. Its value is pretty confined. And it's being multiplied by this function, which gets really small. So that's going to Okay, so I'm immediately thinking that it's not B, because hang on a minute, this thing is positive or 0 as well, so it might be. Then we've got 3 left, and they all look like they're decaying. So now I'd look at the options, I think. Yeah, check some zeros. When is y 0? And also check x equals 0. I like this. So in chat, somebody suggested looking at y equals 0, and someone else has suggested looking at x equals 0, and I think that might be enough. I think those ideas might get you all of the way there. Let's find out. So when x equals 0, well, we're doing sine squared of 0 squared. That sounds like 0 to me. That was like this one, because it should be down here. Sine squared of 0 squared equals 0. I don't care what you're multiplying it by, it's 0. And then we've got 2 options left. So I like looking at the options. For these questions where it's one of the options, I could go and try and sketch the graph, of course, and then compare my sketch to the options, but something I like for these ones is to look at the features that they've picked out and to decide which one I think is good. Maybe I think about y equals 0 as well. Ooh, Anonymous has plugged in x equals 1, which is a bit tricky to do, isn't it? You need to know the value of sine of 1 if you're going to do that, which, I mean, in radians, I don't know. In degrees, I've got a strong opinion, but yeah, okay. Yeah, so it's going to touch the x-axis somewhere. Let's find out where. So when is y 0? Well, 2 to the minus x is not 0. And sine squared of x squared, that could be 0 if x squared, the stuff inside would have to be, so when is sine squared 0? In radians, I'm going to say n times pi. If you like degrees, then your statement at that point has something like 180 degrees in it. And radians weighted is to think about pi instead. If you haven't met radians, then this question would need to be changed so that you could join in using degrees. Right, well, where are these? So for n is 0, and there's the origin again, 1, 2, 3, and so on. So sort of square root of pi multiplied x. So there's an x squared over here, so I think that's square root of pi times square root of these numbers. So square root of 1 times square root of pi. I don't know the square root of pi. What is it? Pi is about 3, square root of 3 is about 1.5, 1.7 or something like that. So I'm interested in this, but I'm also interested in this, which looks pretty good as well. And then what? Help me out, chat. Ooh, chat knows that pi over 2 is about 1.57, and then they're using that to work out. Oh, that's quite good. Yeah, I like that. So I'm faced with this task of working out square root of 2 pi, square root of 3 pi, roughly, but thinking about the shape sounds quite good. So thinking about the shape sounds good. I like this argument that x squared speeds up as x gets larger. So as you make x larger, x squared gets larger, faster and faster. That the gradient of x squared is an increasing function, whatever. It's larger, faster and faster, which means that it rips through things like 2 pi, 3 pi, 4 pi faster and faster, which means that these zeros are getting closer and closer together. So I have a distance over here, and then I have a smaller distance over here, and a really small distance here. Highlighting them is helpful to me, I think. Anyway, so this is getting smaller and smaller, so now I'm really leaning towards A. Whereas this picture down here, it looks like these might be equally spaced. Maybe? It seems to be the only difference between the pictures as well, that this one there, the oscillations are getting faster and faster, if you ask a physicist. Yeah, or maybe you just know how big square root of 3 pi is. It's about 3, it's about there, that's this. Although I noticed this is pretty close to 3 as well. So, no, I'm quite nervous about these decimal approximations that people are doing in chat. Yeah. So it's not, I think this might be 2 to the minus x sine squared of x. I think this might be 2 to the minus x of sine x squared. And I think this might be 2 to the minus x of sine, oh, maybe cos for the 1. It is 0.5. Maybe it's cos. Not part of the question. you know, cos instead of sine, missing the x squared inside, missing the squared on the outside. It's probably what I would make up if I was making up wrong options for this. You might like to think about what you would make up for wrong options for this. What else could you change, right? You put 3 in here instead of 2, but that feels a bit mean because that just goes faster. Decays faster. Too big of a value. What else do I think? I think we're done. I think we've decided that it's A because the oscillation's getting faster and faster. Anything clever? I've noticed that these peaks look like they're getting flatter, whereas these ones look like they might all be about the same shape. And I'm wondering whether there's something clever there to do with transformations of the graph, but I think it might be too clever for me. The way that it's not even quite true, actually, is it? These ones look like tall, narrow peaks, and these ones look a bit shorter and wider because, oh gosh, or maybe it is true. Oh, I don't know. Each one is square root n factor for how wide they are. I should stop thinking about this. We could Desmos all of these if we wanted to. Ooh, 2 to the power of x. Yes, okay. I might do that as a wrong option, and then I might draw it. And these days we have to have 5 options, right? So we might draw 2 to the x, sine squared x squared. You are invited to imagine that graph, which I believe will look like this one, except getting taller and taller. So this kind of envelope effect. Something to try in Desmos if you've got access to the Desmos website on a phone or something, or stop watching this and go and play with Desmos if you like. If you've got some function, then it can be fun to have a look at f of x sine x, which takes your function and uses that as the amplitude. So in general, if you have some function, then f of x sine x, I've drawn quite a sine-like function, never mind about that. F of x sine x lies in between f and minus f of x. Like up and down. I don't know how fast it's going to oscillate. I guess I'm imagining that I'm zoomed out quite a lot, so that sine x is doing quite a lot of oscillations in that range. Whatever. Good. Okay. For 2 to the x, would the oscillations be increasing? The amplitude would be increasing. There are 2 things going on with oscillations, aren't there? There's kind of an amplitude of the waves, and there's a wavelength. We're getting into physics, aren't we? I think I am going to do a quick Desmos, just to illustrate that point, because who knows? This is kind of fun, isn't it? So let's pick a function like x plus 2. And then, let's give it a name, because you can do that in Desmos. And then multiply by sine x. And what do we get? Well, we get something like this, which grows like x plus 2, but also it's bounded between f of x and minus f of x, of course, because sine is between f of x and f of minus x. And look, I've now zoomed out so that it's really up and down. I guess I can change that by putting in a sort of divided by 5 or something. There you go, that's quite nice. So this one looks like it's going faster and faster, but that's just the amplitude getting larger. The zeros are equally spaced at, because of my factor of 5, 65 pi, 70 pi, 75 pi, things like that. If you start messing around with this function inside here, so I've tried x over 5, if you start messing around with this function, then you can create things where the wavelength changes over time as well. What have I done now? I've done something terrible. I regret that. I've zoomed out. So 1 over x is quite fun because that describes something where the wavelength is increasing. I don't know. I like messing around with stuff like this. This one is doing some really weird stuff in between, isn't it? It's still bounded by f and minus f, but because 1 over x is changing really quickly when x is a small number, you get this kind of like packet of lots and lots of oscillations. Let's zoom in on this bit. Oh, that's really nice. There we go. Loads and loads of peaks. As 1 over x rushes through so many values, this little sine thing is sort of, it's like spinning around the unit circle faster and faster, if you like. It's changing through all its values really, really quickly. Right, there you go, sine 1 over x. Usually the first time you see that, it is not multiplied by x plus 2, so I kind of regret that a little bit. That's a little version anyway. Okay. Whee! Okay, right, okay. Enough messing around with Desmos. We've got some math questions to do. Yeah, can you put more stuff inside here? Go. Desmos is free software. If you have energy and time, then you can put all sorts of functions into Desmos. There you go. How to get better at sketching graphs? I used to say sketch lots of graphs. These days, I think I say sketch lots of graphs and also use a computer to sketch lots of graphs, because it kind of feels like cheating. Not cheating, but like the augmentation of how quickly you can see lots of graphs of your own invention. When I was in school, I had quite a primitive graphing calculator that could do, it was brilliant. Now it's just like free software on the web to do, it could do so much more stuff than my graphic calculator ever could. What happens if you put arcsine inside sine? Right, okay. Those are the short questions. For long questions, I did want to have a quick look at this truth or lie one. I don't want to annoy people, I suppose, with the truth lie stuff, but they're just quite nice. We haven't done a truth or lie question for a while. Is that true? I think that's true. Some of the characters have made a reappearance, but I don't think we've done one like this for a while. Oh, maybe you have. There you go. Okay, you've done one of these recently. Time check, 40 minutes. Let's have a quick look at the truth and lie stuff. Maybe I'll have it on the screen. This sort of logical reasoning is, I suppose, not explicitly on the syllabus, but is the sort of thing of no previous knowledge required, but if you're good at problem solving, you could turn up having, I think, not seen a question like this before, and still have a go. Let's do a vote as well for which long question we're actually going to look at, and get chat temperature from chat. Yes, they always start by telling you that everyone is an expert logician, although I suppose this one doesn't. This is the 2007 version, which fails to tell you that they're all expertly good at logic. There's one where it's important that the people in the game know that as well. So the question starts by telling you that they are all well-known expert logicians, so that you know that the person in the question knows that the other person in the question is good at logic. Isn't just saying random stuff. But then on closer inspection, this question doesn't say that, because one of the people is saying random stuff, and there's a bit of process of elimination going on here. The thing I would highlight, I suppose, is not really the truth and lie stuff. It's good because you don't need any prerequisites you don't have any previous knowledge that you need to understand the concept that things can be true or false. The thing I want to highlight instead is the sort of case checking that you can do on this question. For example, there are three people here, right? And we're given three properties. One of them tells the truth, one of them always tells a lie, those are incompatible, and one of them tells truth or lies. Randomly, these are incompatible properties, it's one each. So in some order, they are A, B, and G. And there's not that many orders. So to get us back to something resembling maths on the MAT syllabus, if you like, that's a sort of permutations thing, right? The kind of ordering of these people, or a binomial choices and choosing thing, if you like. There are 6 ways that this could be. 6 is not that many, so you just want to then check whether those are true or not. Good. Okay, people are actually voting for this as well, which is nice. Jammy Dodger wants a big truth table. Fair enough. Fair enough. And do I recommend doing CS questions 6 and 7 to prepare for this year's MAT? I just answered a YouTube comment about this as well, although the other way round. The YouTube comment was from someone doing CS who wanted to know whether it's worth looking at the non-CS questions. And I'm grinning because I think it's hard for me to imagine a situation where I don't recommend doing a MAT question. I just really like doing MAT questions. I think probably if you're just applying for maths, you might skip the CS questions. I've zoomed in on this one. I sort of think it's good for us to look at the CS questions as well. They're using the same syllabus, and sometimes there are questions here which don't use very much specific knowledge and sort of test problem solving, and that kind of slightly harder to pin down skill of just trying stuff. Okay. There's some voting going on. Question 6 is winning the vote, and then note to self, question 2 is looking pretty strong. We'll have a quick look at question 2 in a moment. But I'm aware that we're on 2007, and we should probably think about moving on to 2008 at some point. We need to talk about that one over the summer a little bit. Right, okay. Let's pause that there. So question 2. Right, okay. So, key observation, I think, for this question is that if you always tell the truth, then you cannot say the phrase, I always tell lies. And if you always tell a lie, then weirdly, you can't admit that because you have to lie always. So you can't even admit truthfully in a moment of confidence, I always tell lies, I'm the liar. You can't do that because you've got to commit to the bit of always telling lies, even now. That is, I believe, the solution to half of part I, because that means that alf must be random. Only a random person could actually say this sentence. Definitely not the truth teller and not the liar either. And then Beth says something really weird, which is, yes, that's right. Alf always tells lies, but that's not true. We just decided that's not true. It's not always that Alf tells lies. So I guess, it means that Beth can't be the one who always tells the truth either. So Beth doesn't always. You think maybe they're random as well, and then you remember that no, it's one each, so we can't have a second random person. Doesn't always. I feel like I'm defending Beth in court or something. Beth doesn't always tell the truth. On this occasion, Beth has not told the truth, and then we deduce, unfortunately, that Beth always lies. Oops. So I think this is A, B, like that. And then suppose instead, there's a couple of similar things going on here, where we chase through, if you like, some possibilities or make logical deductions from what we've got in the other parts. Yeah, so alf has to be random. And then are the other parts more interesting? Can I remember the precise logic? Let's find out. Suppose I said that Gemma says, who's Gemma? Oh, sorry, Gemma's the third one. Sorry, this was all about Alf and Beth. Gemma says, Beth always tells the truth, and Beth says that's wrong. So I guess, importantly, they are disagreeing about Beth. I think at this point I would just sort of start checking possibilities. It's a little bit like Sudoku puzzles. If I'm not very good at Sudoku puzzles, and just sort of check possibilities. I find this quite confusing, I think, unless I'm going to go through it. Am I going to go through all 6 possibilities and just check which one's consistent with that speech? I could do, couldn't I? I think I'll leave that for someone else to do. Yes, the names are alpha, beta, and gamma, more or less, like the Greek alphabet. Alf like alpha, Beth like beta. Yeah. And there's a third part where Alf says something about Beth, and Gemma says something about Alf, and Beth says, you have heard enough to determine who always tells the truth, which I suppose itself might or might not be the case. So at that point, I guess Beth's statement refers to the state that I was in just a moment ago. And at this point, the question is whether I'm an expert logician, I suppose, as these questions sometimes say. Expert logician in the sense that, have I heard enough to determine? That depends on me a little bit, doesn't it? So maybe, okay, so cases, maybe I have to chase through all cases, right? Just chase them through again. Right, so like if Alf tells the truth, then Beth behaves randomly. Gemma would be the liar, and Gemma says Alf always lies, which would be consistent, what a lie. Alf is truth teller. But then Beth says, oh, and I've decided that Beth's random, Beth says you've heard enough to determine who always tells the truth, which would be correct, but the sort of thing a random person says, so I'm happy with that. Let's check another possibility. So I'm going through the possibilities for Alf. Maybe Alf is random, in which case I sort of ignore what they say about Beth, right, because Alf is just random. And then Gemma says Alf always lies, which I guess I have subcases now to say, well, no, I've decided that's not correct, so Alf is the random one, so Gemma would be the liar. And then in that case, Beth tells the truth, and I've heard enough. So I think I'm confused, because I think just talking it through, I think these are both consistent, right? Maybe not. Maybe chat can help me out if you're playing along. So if in my first talk through, I think I've concluded that if Alf tells the truth, then Beth is random, and then Gemma says Alf always lies, which is a lie, which is good because I think Gemma always lies. Then Beth says I've heard enough, fine, okay. That's just a random fact in this world. And if this alternative where Alf says something random, in which case I'm ignoring what they say about Beth because it's just random. Gemma says Alf always lies, which is still a lie, which makes Gemma the liar. In which case Beth is the truth teller. And Beth says you've heard enough to determine who always tells the truth. Yes, I have. I've determined it like this. Oh, so maybe this is... maybe it's... right, okay, so maybe at this point, the fact that there are two cases. Let's look at chat. These questions require you to be a detective, yes. Is there a resource that tells me about the details of the exams? I better giving a written paper to use a computer. Okay, so you need to look at the MAT page, which I'm going to link you to, which is like this, and then depending on your question, depending how detailed you want, you might look at, depending on how much you want, you might need to follow the link through to get some sort of information about taking the test, which might take you to this kind of tests page. So I'm linking you to both. But for people watching the recording, I'm linking them to basically MAT Livestream and then upper level. Right, so I think Beth's statement is now, overall, globally speaking, I think this is false. That if I know what Alf is, if I know who Alf is or what Alf does, sorry, then I would have had enough, but I don't. It could be this or this. So now I've got a sort of meta level, haven't I? Where like a second level of this going on, where I think both of these sets are consistent with the first two statements. Which I think means that Beth's third statement is a lie. Which then, I should think about the third possibility, right? I haven't checked what happens if Alpha's a liar, but maybe afterwards I can deduce which one of these it is. Let's just quickly run that through. If Alpha's a liar, then Beth is not random because it's a lie. So Gemma is the liar. Gemma is the random one. You know, Alpha always lying could be quite a helpful thing because it means that the opposite is true. Beth is not wanting to behave randomly would be a true statement. Okay, and then Gemma says Alpha is the one who always lies. Oh, true, truth. Oh, I've labelled Beth and Gemma the wrong way around in this case. No, I haven't. Beth is the one who behaves randomly, and Gemma says Alpha. Well, Gemma says something and I don't care because in this case Gemma is the random one, so I'm ignoring Gemma. So it could be this as well, right? It could be any of these cases, and all of those are consistent with the first two statements, but then Beth says something that isn't true, revealing Beth to be the random person in this middle case. Oh, that's pretty good. Scroll your screen. Yes, am I off the bottom? Sorry. And I also went really small and wobbly, but I was talking out loud. So this was a weird twist at the end, which I didn't practice before going live on the stream. There are three possibilities for Alf, and each of them leads after the first two statements, each of them leads to, I think, a consistent set of allocations for who's telling the truth, who's lying, and who's speaking at random. The key thing is, if they're speaking at random, then I'm ignoring what they say, which happens a couple of times. Once when Alf is a random person, once when Gemma is a random person as a consequence of Alf's lie. But in two of these cases, Beth tells the truth all the time, and then Beth, in this scenario, Beth says something which just up to Beth says you can work it out from here, right? And I really can't. So thinking about it, I think it's the only MAT question where you get halfway through, you haven't solved the question. The question itself says you have solved this question, and you're supposed to say no, I haven't, and that's how you make progress. What a weird question. I've never done the last part of that, I think. How good were you at MAT while applying? I did not apply to Oxford. And also, when I applied, there wasn't very much MAT, so I didn't even know, because I did not look at MAT past papers. I didn't even know any. Good. Go through the conclusion you made from all this. So I did the kind of case checking thing to think about focusing on Alf. Is Alf telling the truth or lying or random? And then following through some consequences in each case. And there's quite a lot of consequences in each case. But in each case, I get a kind of consistent picture that's fine with, I include the information of Gemma saying Alf always lies, and now I've got some deductions. In each case, I've now deduced which way around they are. But there's these three cases. So when Beth then says, you've heard enough to determine who always tells the truth, well, I hadn't. So that's a lie. Because just before Beth said that, I had three cases on the go, three possibilities. So Beth says that, and that's a lie. And actually, weirdly, there's only one case. You might expect the cases to come down as truth, lie, random for Beth, but it doesn't work like that. The consequences go truth, random, truth for Beth. So there's only one where Beth has the possibility of lying like this. And it's an insulting lie as well, because it's a lie that implies I might have worked something out when I haven't. Okay. Good score from Oxford. I would not aim for 60. I would aim for 100. It's out of 100. Good. Cool. Okay. That was question 6. People also wanted to have a quick look at question 2, I think. So we'll go over here. Didn't we talk about question 2 before? I feel like this might have been in the polynomials worksheet. Maybe, maybe not. Importantly, F1, if you're doing this question, F1, this n equals 1, it's not as bad as it looks because this cancels out. So this is just 4x plus 1. So then what you're being asked to do is to repeatedly quadruple and add 1. So if you do a couple of these, you'll find that you have things like 4, and 4 times 4, and 4 times 4 times 4, and so on. So I think what you've got is some sort of geometric thing. That's my expectation anyway. Is that true? Yes, the constant's on the end. To start off with, you have 1. When you multiply that by 4, you'll get 4. Then you add 1 for the second time that you do f of x. So this is 16x plus 4 plus 1. And this one is, it's another multiply by 4, multiply by 4, multiply by 4. So the things I had times 4 plus another 1. So you get this geometric progression, which will be fine. And then F2 at the end, they try to scare you by trying to get you to do this calculation with n equals 2. But they only ask you for the degree of the polynomial, so that's not too bad. You are repeatedly squaring in this case. So laws of indices for what happens when you square again and again and again. You'll be all right. You guys really like nested functions, is the comment in chat. There you go. I don't think nested functions are easy, because if this question here said, what is that? If it said, find an expression simplified as much as possible for, and then give you this, well, bad news, that's really hard to work out. nested functions can be really hard. Right, okay, we're hitting 6 o'clock, and I think it's time for a little bit of 2008. We had a look at 2008 last time because I thought that last time we would mostly talk about technique, and then we ended up talking about questions quite a lot. So if you've had a look at 2008 since then, last time we had a lot to look at this sort of Ox words down here. We met the Catalan numbers. We differentiated some polynomials. It was a whole thing. I'm going to turn on the vote because we only looked at a few of the short questions. So if you have a multiple choice question now from 2008, now is the time to vote for which one you'd like. I've circled J. If nobody votes, I'll go for J. Also it's 6 o'clock, so if you have been looking at a screen for the last hour, this is a reminder to blink and look away from the screen. And I'm drinking some water. Remember, you are human. Right, good. As a request in chat for 1C, which is doing all right in the votes, so I sort of think probably not that. To answer a question in chat, part of my job is to make sure that Matt gets set and marked. It's sort of my responsibility to make sure the thing happens. And then someone's asked, in the Matt this year, will there be logic long answer questions, which is a great example of the sort of question that I obviously can't answer for what are the questions this year. That one was in polynomials. Thank you. Someone in chat says that was in the polynomials worksheets. If you've been playing along with the worksheets on the Matt Live website, then you might have already seen some of these because we use past paper questions in those. If you would like to see those, the advantage of seeing them in the Matt Livestream worksheets is that we wrote some hints and we wrote more detailed solutions for the ones that we picked out there. If I had infinite time and resources, a phrase I seem to be using quite a lot today, if I had infinite time and resources, I'd quite like to do sort of that treatment for all Matt questions, but there are way too many. So it's the Matt Livestream worksheets where we've gone into that slightly more detail of how would you do this question, what are the hints that you would need for if you're stuck on this question, and also the solution. Is there a statistic for how likely you are to get in if you are pooled? And that's a question for Cambridge, because the concept of being pooled is a Cambridge admissions thing. We don't do that in Oxford. I suppose in a way at Oxford everyone is always pooled because anyone can be made an offer by any college. What's the current format in terms of questions? There are 25 multiple choice questions and 2 long questions. The long questions have multiple parts. For more information about what the MAT is like, please see the website. Please have a look at the format of this test that you're going to do, so that you know what to expect when you get there. There's lots of information and resources on that. Good. 1J is winning the vote, so I'm going to zoom in on 1J. I'm going to remember 1C is second at the moment, so I think like that. There we go. Thank you for voting. Maybe if you want to do a long question instead, we will do a vote on that very soon. Concept, yeah, combinations, binomial exponential probabilities. Yeah, not too much. Combinatorics would be a scary thing to put on the syllabus because there's loads of combinatorics. Brilliant. Okay, so this one's in the thumbnail, so I guess we should think about this one. Here's the equation. We're asked how many solutions it's got. I think I'm going to be a bit lazy and I'm going to ask chat for ideas. Over to chat what you think is going on. My instinct is to try and draw both graphs, to try and think about how large the values are, to see if I can find points where they cross over. I'm not going to maybe I won't be able to find precisely what those points are. I might try plugging in some values. Might think about limits. Yes, I'm thinking about limits. Sketching it. Sketch. Yes. People in chat very keen. Are the long questions harder since there are only 2? Well, I can't comment on how hard any question is, right? But we're not trying to. We've got 25 multiple choice questions. We've changed several things about the test. Good. Okay. So graphing this then, 3 plus cos x. 3 plus cos x, I'm going to do this in stages, I think. 3 plus cos x. So as large as 4, isn't it? And then down to 2. 4, like that. We're on 0 to 2 pi, but if you prefer to see 360 degrees, then there you go. 4, and it goes as low as 2. We've been asked to square that. I might think about that in a second. And over here, 4 minus 2 sine to the 8 is quite exciting, isn't it? What does that do? So sine to the 8 is positive. So this bit here that I've underlined is between 0 and 1. So we're subtracting maybe as little as 2 times 0, and maybe as much as 2 times 1. So this comes down to 2 as well, doesn't it? That's nice. And I'm drawing something cos shaped when I should be drawing something sine shaped. No, because of the minus sign I was right the first time. Like that maybe? Maybe? Something like that. The power of 8 probably makes this shape a bit different. Maybe I should think about that. But I've noticed the left hand side thing is squared. And now I have a strong feeling about what's going on in this question, right? You could use, oh my goodness, so someone wants to use, expand that into cosine. And then you have a polynomial in cosine. Oh, right, okay, I feel this may be more work than the question setter imagined. But you're right that that is 1 minus cos x squared, and then to the power of 4. And if you expand that, you will have, oh crikey, degree 8 polynomial in cosine of x. That's, degree 8 is quite a large number. Yes, it's going to be not a nice time, I think. Sorry. Could you solve this algebraically? Wow, so this is what I'm considering right now, right? Could you swap this sine to the 8 with a 1 minus cos squared to the 4? I don't really want to do that. Because I think, oh, someone wants trig identities. Oh, maybe the trig identity they're thinking of is this one. It's good. You could multiply it all out. Has anybody got that to work? That's a tricky question, isn't it? I can't see what the next step is, right? Now maybe I can see one step further ahead than chat, but the thing that really concerns me is, well, all of this bit, right? So 4, this is going to go off the side of the screen. 6, this is sort of, it's still going. Don't worry, you're not missing out very much. Underneath chat, I'm still going, I went all the way over here. This is awful. And sometimes when you've multiplied something out like that, or halfway through multiplying out something like that, I tend to lose patience or think, surely not. Oh, difference of 2 squares is quite a fun idea, so you can factorise that. I'm still going with the ideas, I like it. 4 is 2 squared, so this is difference of 2 squares, so you can factorise that. That's an idea. Do I like it? A little bit. I mean, my experience of trying to solve polynomials like this, or solve equations like this, is that you kind of want to multiply everything out, because the stuff on the left is going to mess up all of your coefficients. And while it's true that the coefficients currently are quite nice and could be factorised, that's, I think, not a factor of the left-hand side. Yeah, it's not a factor of the left-hand side, is it? So we don't get to cancel that factor. So, might have to multiply it all out. What's the question you were asked most by chat during the live streams? It's maybe what's a good map score, because that's the one that seems like the most important question, and it's the one to which we don't really have a precise answer. So I think that's the one I get asked the most. What's a good map score? I'm going to switch off chat just in case anybody wants to see that. Yeah, you didn't want to see that, did you? Yeah, so chat has also had a good idea, which I like a lot. Not that the other ideas aren't good, I just can't see step 2 of like what you do next. Whereas if I finish sketching this, because I didn't finish sketching this, then I find something quite surprising, which is that this thing goes from 16 down to 4, and hang on a minute, the right hand side goes from 4 down to 2, so they live in totally different ranges. This one's quite large, and this one's not very large at all. It's less than 4, or maybe equal to 4. And the only points where it's equal to 4 are here, here, and here. The only place this point's equal to 4 is here. So, I guess they match up in the middle. And this question is actually a bit silly because, well, if you try and sketch these, they live on totally different worlds, and they look something like 16 down to 4 like this. So there's only one point where they're equal, and it's right in the middle. Let's just double check that. Let's just double check that at, am I using degrees? Let's go for degrees, 180 degrees. What have we got? We've got, that cosine will be -1, which is 2 squared. And on the right, we have, that sine will be 0. Good. And this is true as well. I know a very good joke about the number 4, but I'm too squared to do it on the live stream. Yeah, so B, one solution. X equals pi in chat, there you go. Chat loves radians. I recommend using the step support program, only the foundation modules. So I'd recommend the foundation modules because they are close to the MAT syllabus. The other ones, if you look at them and if you know the maths that you need to look at the other step support modules, then they might help you with problem solving skills. The reason that I limit my recommendation is because I don't know what other maths you know. This is the weird thing that everyone doing maths knows about twice as much maths as the MAT syllabus covers, but I don't know which way that twice as much goes. The Venn diagram is something like this, where everyone knows the maths in the middle, and then each person knows the maths on that side or the maths on that side. But it makes the recommendations a bit hard because I don't know which side of the Venn diagram you're actually in. No, you're not in the Venn diagram. Your knowledge is one of the circles. I don't know which circle you are. You're a circle. The Venn diagram is not a good Venn diagram. Right. Would I recommend memorizing sine, cos, tan common values? I think that's a good idea. I would call that a trigonometry skill, really. We have some trigonometry on the syllabus. I don't think it hurts you very much to memorize. There's not that many good ones, right? Isn't it true that if you can get from 0 to 90 degrees, then you can blag the rest by working them out from the rules about symmetries of sine and cosine? You can probably get to 90 degrees. There's only a few special numbers between 0 and 90 degrees. Good. What was the question you were asked the most that you ignore / don't answer? Brilliant. Good. Let's look at some long questions. What have we got? We covered a lot of these. Maybe we don't need to do any more of these. We'll look at 7. There's another truth-lie question, which I don't think I should try and do this one live on the stream. There are 3 of them, and we've got this sometimes person again, so it's basically the same setup as the previous year. It's a little bit before my time that we did these. I wonder whether they were getting predictable at the point where my question has the same sort of premise as the previous year, which we wouldn't want to be predictable. Quick check in chat, just let me know in text. I think we should move on to 2009. I think we've looked at some of these long questions already from 2008, including there's one that we did on a worksheet. So I think we've maybe mined this for interesting things. I've circled question 5, but I mostly circled it just because it's quite a nice question, not because I think it's a particularly useful question for us to look at and think about a lot. Yeah, I forgot which way around I asked the question, sorry. Evidently I asked it as a yes/no question. Hang on, can I watch the live stream to watch it back to see which way around? Yeah, people are agreeing that we're moving to 2009. We're moving. I've got some picks, but we're moving to 2009. Let's do one short question, and then Ivy wants to do question 4. So let's do one short. We've done a few shorts, but if there's a short question, is it J? It's usually J that people want to talk about. Sometimes sorted. There's a couple of people voting. Is that 2 people voting? Interesting. That's 2 people voting for precisely the same subset of the questions. Oh, maybe this is going to be J. Maybe I don't need everyone to vote. How soon? Because J, we could talk about the answer for J, but it's kind of also the strategy for J, isn't it? That this looks like absolute rubbish. It's got so many terms in it. How could we possibly like solve this or count the solutions? But I like the way the question contains clues. There's the fact that all of the options involve powers of 2, plus or minus 1, or 2, or 1, or 2. And there's the way there's a big power of 2 in the question. These integers need to be a bit special, don't they? The thing on the left has to be a power of 2, 2 to the power of 30. And it doesn't really look like it's anything to the power of 30. Is it something to the power of something else? And then you're starting to get closer to the truth. So I think for me, if I had that eye tracking software, it would be something like powers of 2, powers of 2. What do I think? What is the relationship? There's a huge number in here, and then there's probably some relationship between the huge number they've decided to put on the right hand side and the options in the question. And then it's for us to work out, you know, almost if you like in general, if I put a huge number over here, roughly how many solutions do you get? I probably shouldn't do it like that. I should probably do it properly. But my intuition is this is a bit like, I don't know, if the huge number is x cubed and 2 to the 30, so about 2 to the 10 maybe. That's my first guess. Where I've got kind of some cube numbers going on in there. And there's a cube over here as well, isn't there? Because that's 2y cubed. Then I start to look in the inside ones. So I guess the eye tracking software bounces around over here, and then looks to say, can we simplify this? So I see x cubed, I see 2y cubed, and then I have like close look at these before I decide that this is actually x plus 2y all cubed. At which point the question just completely falls over, because now, you know, like we were talking about doing the integral to turn it into a quadratic, well, there's no challenge anymore, right? We defeated the integral. Here, once you've defeated the cube, defeat the cube, that's the first album title, there we go. Once you've defeated the cube, then the question is much nicer, because now we have a nice little sum that's supposed to be 2 to the 10. I still feel like it's 2 to the 10 number of things, but I suppose this bit has got to be even, so maybe that feels like about half of them. And I should try harder to get the right precise number, but it's starting to feel more like 2 to the 9, because if I just take x to be anything, then this bit might be even or odd. Half of them better. That kind of thing. Why are there so many votes for H? H is there's lots of votes for H as well. A quick look just to see. H uses the trapezium rule. And I think my feeling about the trapezium rule is, if you haven't learnt the trapezium rule, then I think it's not worth learning. Sorry to the trapezium rule and fans of trapeziums in chat, but it's very specific knowledge, which here it is interesting that here it's combined with a sort of geometric series. But this question is really just do the trapezium rule. So if you go and look up the trapezium rule and then come back, then you're almost done with the question. So I suppose one thing to do is, if you haven't learned the trapezium rule, then don't take it personally. I think you could solve this question by looking up the trapezium rule and then just applying it to that function, and I think you'd have a lovely time. I think you probably have to do a geometric sum. I can see all of these powers of 2 hanging around. I can see 2 to the x. I know that the trapezium rule involves a lot of adding, but there you go. Yeah, so some countries it's not taught in high school. Complete the square, defeat the cube. Oh, we're getting the lyrics. There you go. So to be clear, you do not need to know the trapezium rule for MAT in 2025. This is a past paper from 2009. People seem quite interested in this question, so I've zoomed in on it, but I'm now going to back away, right? Because the trapezium rule is no longer on the syllabus. You're not expected to know what it is. I had a look at it to see why chat was so interested, but I think it's there if you want to practice the trapezium rule, and if you haven't learnt it, then don't worry about it. We had a big syllabus change in 2018. As a reminder, while they're voting for a long question, as a reminder, if you are looking at a past question and you think it seems weird and you don't know what's going on, then it's a possibility that it's something that's not on the syllabus anymore. So on the MAT page, there is the current syllabus if you want to check what's on the current syllabus, but even more explicitly than that, if you're looking at the table of past papers, then for 2007, there's this button, or 2009, there's this button you can press that says Notes, which has some helpful notes like, this question assumes knowledge of the trapezium rules. Trapezium rule. MAT questions from 2018 onwards do not assume knowledge of the trapezium rule. Answers the question, do I need to know this? And only one that year, which has been flagged as using radians. One of the changes we made in 2018 was radians. If you are on this page and you scroll up to 2018, you get this is an archive of the text that we published in 2018 due to A-level reform in the UK. So if you care about what happened in 2018, then that's on there as well. Good. Defense of sequences and series. Oh, people are voting for CS. That's nice. I'd quite like to finish the day on CS. Well, I guess we've got time for maybe one or two of these. So I'm going to let them keep voting to see whether 4 or 5 comes through. 7's the one I've circled. It's talking about valid sequences. It feels a bit like those Oxwords that we talked about recently, or were they sequences of tiles or something like that? Oh, I do like this question. I think I do this question every year on the live stream when we go through past papers. So possibly if I dig back through YouTube, I can find archived versions of me talking about this question once a year. Here we are again. Hello. Valid sequences are made according to the rule that you can't have an M next to a W. So these are fine. And these ones, no, not that. No, not that way around either. And surrounding by X's, that didn't confuse me. You're not allowed to have them next to each other. Part 1, clearly, there are 3 valid sequences of length 1. Oh, I see. M, X, W. List all valid sequences of length 2, and this is checking that we've understood the rule. So I guess, I suppose maybe my strategy for this is to write down all 9 without thinking, and then cross out the ones that are banned. How many will be banned? I think it's 2. Maybe I'm clever enough to not write down NW. And then XM, XX, XW, that's all fine. And then W, I think I'm clever enough not to write down WM. Good. I thought I'd have to do some crossing out, but I didn't. There are 2 that are banned, so here are the other 7. I hope that's right. Okay, sequence time. G of n is the number of valid sequences of length n, and we are asked to explain these. But the question has a lot of structure to it. There's a lot of reading to do here, right? Where they tell us to introduce this new notation, m of n, x of n, w of n, to denote the number of valid sequences of length n that start with those things. Explain why m of n is w of n. So if you start with m, why is that the same number as the number of sequences that start with w? I don't know, you can't just change the first letter, can you? Because the next thing might be different. I suppose you can swap all of the w's and m's. They're quite symmetric, aren't they? So given a sequence with m's and w's, you can swap all the m's and w's. Which gets you back. We've had quite a few MAT questions that are a bit like this, by the way. So I'm going to sort of run through as much of it as I feel like doing, until I feel like it's just calculation. But we've had quite a few MAT questions like this where you set up something recursive, or something where values of a sequence are defined by previous values of that sequence. In fact, that's on the syllabus, that sequences defined iteratively is a thing where the sequence is defined by previous values. The thing that we've done in MAT questions a few times is to have more than one sequence. So this has got 3 sequences, m, w, and n. M, w, and x, those are the sequences. They depend on n, and they depend on each other. So it's a slightly more complicated version that we can walk people through. there've been several of these questions where you come up with some formulas and you explain using words and logical reasoning why a formula like this holds, and then the thing that happens next is you do some calculation, and maybe there's a separate part of the question. But those are two separate things to do, I suppose. The idea about explaining using words why some equations are true is quite separate from then actually using it to calculate. So, separate things. 4 and 5 both doing very well in the vote. Let's pause that there. Oh, I've missed loads of chat comments while the voting was happening. How do you use the values of A and B? Oh, I remember that question from before. For the how do you use the values of A and B? It's because at that point in the question, I'm talking about a particular sequence xn, which I've used those values of A and B to calculate the values of x and n that I'm doing. The definition of xn and yn has A and B in it. So without using particular values for A and B, then my numbers would involve A and B. They're telling me to use the numbers for A and B that I had from a previous part, rather than, oh gosh, it would be horrible, I hope no one did this, but just keeping them as A and B throughout all of that last part. The question is telling us to not start again. Don't start again, just carry on, keep going. So it looks like I'm not using A and B, but because I'm just carrying on. Good, okay. I do 3 A levels, my third being psychology, that's fine. If the first two are maths and further maths, then that's fine. We know that we're making a big request by asking people to do maths and further maths already. We don't have any requests for your third subject. Right. Okay, so I've got this rule that maybe you can swap all the M's and W's, and that seems fine. They're kind of treated symmetrically, aren't they? If they weren't next to each other before, then they won't be next to each other afterwards, after doing that swap. What's this then? So this relationship, as always with these kind of recursion things, where you're trying to relate a problem down to a smaller version of the problem, you're trying to think about the kind of choices that you can make at the start and then the consequences of what happens. So here they're telling us that it starts with M or X or W. So over here, this is one starting with M, and then that's a choice. So you could start with an M. I think we're going to add these together, aren't we? You could start with M, different possibilities for the first letter. You could start with M, but there's a consequence, which is then your second letter, the rest of the sequence, I suppose, starting with that second letter, where the second letter can't be W. So you could have a sequence of length n-1 that starts with M, i.e. you had an M and then another M, or you could have a sequence of length n-1 that starts with X, thinking about the sequence after the first letter. So this bit is what's allowed after that first letter. And in this case, there's a factor of 2 here, because after an X, you're allowed an M or a W. So I suppose I might write out 3 terms on the right, because I'm allowed 3 sorts of things. I'm allowed sequences of length n-1 that start with an M, or an X, or a W, but 2 of those terms are equal because the sequence M and the sequence W have the same values. So W of n-1 is equal to M of n-1. So you can't see the W term in this right-hand side. They've simplified things a bit. What does computer science and philosophy involve? Computer science is some of the courses that computer science students do, so nothing different there for the ones that they do, and they spend about half their time, in first year at least, studying philosophy. They're not restricted to the sort of philosophy that's useful for computer science. They're also able to take other sorts of philosophy. There's details on the course website somewhere, I think, if you're interested in that joint honours course. People doing it, I think, tend to be a bit interested in AI ethics, but you don't have to be. You could be interested in computer science and interested in medieval philosophy, if you like. Right, what was I doing? Oh yeah, we're going to do some calculating. The GN, the total number, I'm pretty sure is the sum of these things that you could have. You could start with an M or an X or a W, which is another sort of M. So that's, I think, G. Seems all right. Okay. So this is kind of the classic recursive question, where you need to understand where equations come from. It's usually come from something where there's some relationship between a problem of length n minus 1 and a problem of length n, problem of size n minus 1 and a problem of size n. If you've studied mathematical induction, which is a proof technique where you go from n minus 1 to n, or maybe you phrase that as k to k plus 1 or something, you gradually increase the size of the number in your problem, improve it one by one. If you've seen all of that, then you've seen something else of that shape, right? Where you start with small problems and you build up. That's not what it actually feels like to learn mathematical induction in sixth form, I know, but probably it feels like some magic that you write down that gives the answer in the question. But hey, that's what it felt like for me anyway. I don't think this question does find an equation for these things, because that would involve a power of a matrix, which is very much not on the MAT syllabus. Do you need a power of a matrix? No, you could probably just guess there's some power rule going on here for what's going on. It's a good question, Ginger Biscuit in chat. What's the actual answer in terms of n? I think good follow up, but I think it's weird. My guess is that it's something of the form a times another number, and another number. So my guess from solving similar problems is that it might be something like this: some numbers at little a and little b, and then some coefficients big A, big B, big C, big D that go together to give you this combination. I can imagine a part of this question which says, assume it's of this form and plug these in, good luck. But luckily for us, the question does not involve any of that and instead talks about reflexive sequences. That last part is very specific to this question. So if you're having trouble with it, I wouldn't lose too much sleep. But there's this idea that you're turning the sequence upside down, you're rotating it about the middle letter. Is that what's going on? Yes, I think so. You're replacing all the M's by W's. You're turning them upside down. Yes, and you're reversing the letters in the sequence. So you're taking a sequence like MXW and you're rotating it. Can I do that in Miro? I can do that in Miro. Wow, it's got back to where it was. That's great fun. I'm taking another one. It's very specific to this question, right? But the idea that you're rotating the sequence upside down so that all the M's and W's are swapping. What's chat doing? Is chat trying to interpret statistics? Chat, I would really warn you about statistics and probability, but I think we'll go there. Is there somebody on YouTube saying that maths and CS is easy to get into? That is a bold claim to make on YouTube. That's coming from me, always making bold claims on YouTube. So my chat says Hermitian conjugates. Can I remember what a Hermitian conjugate is? Not really. Right, okay. Right. I think the middle letter has to be X, so that when you've written it backwards and done the swapping, the thing in the middle wasn't affected by writing it backwards and might have been affected by the swapping. We want it to be the same, so it's going to be X in the middle. And over here, you're looking at what's on each side. That you've got sequences starting with X of a particular length, and then setting the right-hand side determines what the left-hand side must be so that it does this rotational property. That's the idea for the question. It's very specific to this question, so I'm doing it very quickly without really looking at the question. I think people were keen on 4 and 5. I can't quite remember which way around, but I think it's the suggestion for what we might do at the end, unless you want to do 25 minutes of chat. How about we compromise? I think I'm running out of steam. 5 is in the thumbnail, so people might have clicked on this to find out about question 5. It looks like this. Trying to walk around visiting every square on this grid. It's quite a lot of reading to do, isn't there? There's an n by n grid of squares, and you're trying to visit all of them. And then suppose now that you are a robot that is doing this using understanding 2 commands, R, which turns clockwise through a right angle, and F, which moves forward. Yes. Okay. Thank you, chat. Right, chat. Here we go. Oh, official. It's on an official channel. Okay. Is it harder to get into maths and such as maths? Only 5 people were given offers last year, I think. Big news. We haven't admitted anybody for maths and stats in the last couple of years because a few years ago we merged admissions for those things. So in 2025, nobody will be admitted for maths and stats because that's not a thing you can apply for on UCAS. The thing you can apply for on UCAS is maths/maths and stats. And what we've done is we're admitting everyone together for the same G100 thing on UCAS, and then we'll work it out when students get here. That's a flippant way of me saying that students have the option to choose at the start of 2nd year whether they are on the maths course or the maths and stats course. We no longer make anybody decide when they apply on UCAS. You just go for the G100 thing with the both. There you go. Admission conjugates. I think it's the attitude of switching things. I saw them explain what those were, but they're going to put more stuff in as well. Vibes and robots. What maths rules? Somebody, I think I missed the thing, it went by in chat quite fast there, but someone asked, can you use mathematical induction? To which I think the answer is yes. Please make it clear what you're doing, that you can use maths that you know, provided that you follow the instructions in the question and that it doesn't make the question trivial. So if you look at this and say, there's some chess things, there's somebody in some chess things, so I saw the answer in a newspaper. You are advised to engage with the question or something. I don't know, I'm making that up. I don't think this has been in a newspaper, but let's say you'd seen it as like the newspaper theorem or something. Then even if you've seen some maths that you think makes this really easy, then you're encouraged to still try and do the question as if you hadn't seen some maths that makes it easy. Occasionally people want to bring in something like some sort of high-powered graph theory or something, which normally doesn't go very well when it happens. It's quite rare, but sometimes people want to use some sort of advanced theory that they've seen on some sort of, I don't know, some course somewhere, which is usually a bit of a mess, but hey, there we go. I've said usually as if that happens a lot, when really I'm just thinking about one question from a couple of years ago where something about the way the question was phrased made a certain sort of student think, aha, graph theory, and then whether or not they knew any useful results from graph theory, but never mind. We designed the questions so that you can do them without using weird extra stuff that you might or might not know. It's not really a test of your breadth of knowledge, it's a test of depth of understanding in a lot of ways. Right. With the first one, it says you just go and do it. For any value of n. Oh no, n is even. Any even value of n. Assuming the first command is an f, what is the value of lowercase f? That's how many times it moves forwards. So you're being asked how many times it explores a new square. So parts of questions like this, I've skipped the first couple of bits because I think they're fine. Draw your pictures and then point at your pictures a little bit. Questions like this down here, it contributes to the effect that there's lots of text on the screen, but some of these parts of the question are really just trying to reward you for understanding, comprehending what you've just read. We've got this new block of text about robots, and then this part here is checking. It's not really checking that you can think about tours anymore, it's checking that you've understood the idea about what lowercase r means and what lowercase f means. This is modelling a thing from the mathematics degree where quite often you have a complicated definition, or you have just something new that's defined, and first thing you've got to do when you see one of those is to check that you understand what's being defined. So I'm modeling that just a little bit by giving you this thing about robots, and I guess it's 4 letters because there's a capital R, there's a capital F, there's a lowercase r, there's a lowercase f, but you're picking up marks here for explaining why the amount of spinning is a multiple of 4. There's something going on there with 90-degree turns or something. So you're being checked that you working with it. Does your thing, if it trivializes it, also apply to things like AMGM, which make lots of inequalities quite trivial? Be careful, because there are occasionally questions which ask you to prove. So I've seen past math questions which are essentially, you're proving a thing which is basically AMGM. If people don't know what AMGM is, please be reassured that I'm just talking to that person who said AMGM. I've seen past math questions where you could maybe use it, but occasionally I've seen past math questions where you're being asked to prove it or explain why, and then I think I would go the extra step of, it's usually just for 2 things, so I would usually go for just explaining why the AMGM inequality is true for 2 things, which is super easy. If you've seen AMGM, you should get that mark for explaining why it's true. That's my personal preference. I like to know for sure that I've explained it in the way they were expecting me to explain it. But to be honest, if you just say AMGM, then it's hard to not give people marks for that. If it's permitted by the question, it's hard to not give people marks. Yes, right. So it's rewarding you for applying new knowledge. Yeah. And then you see we've got, must the results of part 3 still hold if the robot starts and finishes at the center of a different square? Explain your reasoning. So now we are being tested on that combination, to take the new information, combine it with what we were previously talking about with tours. So overall, this part looks like huge, right? It's enormous. It's like this much stuff. But some of it is just talking about right angles are 90 degrees. The maths concept here is that 4 times 90 is 360 degrees, a complete turn, or something like that. It's facing in a direction, it'll end up facing in a direction, I think. And then doing something to link it back. So you're kind of introducing knowledge and building to link it back or something. I suppose if it starts and finishes in the middle of a different square, then it's still going to do the same total number of steps because it has to visit all of the squares, but I'm less convinced about the rotation. If the results both still hold, then it's quite a boring question, so there's a clue there maybe that it's probably not just, yeah, sure, they both still hold. There's probably something about rotation. We've got a picture on the question. We could think about starting in a different square there, and I suppose this is an evolution of the argument, whatever it was, that we said for why r plus 1 is a multiple of 4 over here. So checking our understanding of what we were doing before. And then finally, show it's not possible when n is odd. I think that's a sort of last part of the question that's just a bit separate, and might or might not be something to do with the knowledge we've been accumulating. My favourite math questions are ones where the last part is related to all of the things we've been doing before, and it kind of brings everything together at the end. I suppose not for any particularly good admissions test reason, just that feels tidy. It just feels tidy if it brings everything together. I think this one doesn't. I think this one wants to ask about this even odd thing going on, and the punchline is perhaps that the tour is not possible when n is odd, which as a punchline, something's not possible. Fair enough. Am I allowed to use complex numbers, roots of unity to solve a question, like if a question that asks you to find a vertex on a polygon? You could, I suppose. I can't really see what that gets you. That sounds like a really complicated way to do the same thing. Like if you're in your example to find the vertex on a polygon, that's just trigonometry. And I worry you might be making it more complicated. That's kind of how I would get a computer to do it, actually, by thinking about it now. If the computer knew about complex numbers. Again, if we're talking about convincing someone else that you know what you're doing, then it comes down to how you explain it, rather than which topic are you using. But I suppose to your general point, you are allowed to know about complex numbers. You could use complex numbers on this one, right? This could be the complex numbers, right? Because you when it rotates, it's being multiplied by I, or maybe multiplied by minus I. I think this is probably a terrible way of talking about rotations for this question, but I know that chat really likes complex numbers, or maybe half of you like complex numbers, I'm not sure. I think some of chat likes complex numbers, so maybe I can't stop you from talking about complex numbers here. Right. Are the new MAT long questions more similar to this fifth one? Again, sorry Bob, I can't tell you what upcoming MAT questions are like. You've got long questions from last year, so I guess we'll get to 2024 at some point and look at last year's long questions, and you can tell me. Ginger Biscuit's question at the top there says, how much rigour is usually required to do MAT questions? And this is quite tough, because I think some people, when asked to explain something, will write almost nothing. And for those people, I need my message to be, please write something. Please don't just give. And if you've been asked to explain something, please, ideally put some words in, maybe a sentence, but trying to write down something to explain why. This is also a battle I have sometimes with students on the course who have been asked to do something on a problem sheet and who have maybe just written down some numbers or some integrals or something. So there's some people I need to reach and say, oh, please write down just something to justify your answer when that's the question. But then there are also people who have just done the question correctly, but are worried that they haven't done it properly or something. And to those people, I need to say that if you've done the question and you've demonstrated that you know what you're talking about, that you're not just bluffing or making something up, then the bar is maybe lower than you think. But you don't need to imitate a maths professor or something. You don't need to be super professional. We know that people are not maths professors when they're applied to Oxford, or super professional. So I think it's not. I don't think rigour is something that people should worry about. I think being correct is something that people should worry about a bit, because usually the bar is at, is your argument correct or not? And sometimes people's arguments are so patchy that they are basically incorrect because there's some missing logic or there's a missing idea. And sometimes when you're marking things, not all the time, but sometimes when you're marking things, it's about whether there's any evidence that the person has had an idea and thought about something that needs to be treated carefully. If something is true when n is even and true when n is odd, but true for different reasons, then when you're looking at someone's work, you kind of want to see that. You kind of want to see that they've thought about that rather than just telling you that it's always true. I mean, it is always true, so it's a correct statement, but isn't that also what you would write if you hadn't thought about the odd-even thing? So then the amount of rigour is to, well, show me that you've thought of the odd-even thing in this hypothetical example, and then in each case, say enough to show that you've had an idea for why it's true. Is the personal statement even useful for maths? It is useful because it's a free text box, so occasionally it's got something in there that we wouldn't get on any of the other bits of the application form. So I'm glad we've got the personal statement. But if you're talking about the bit where everyone says how much they like maths, maths is the centre of my life, then we're not comparing how much people like maths across different personal statements, if that's what you mean. Why is chat talking about quotient rings of real polynomials? Chat, can we... Was it the Hermitian conjugates that got people excited to sort of start talking about whatever other maths they know about? Right, good. Okay, can we say watching demonstration interviews for maths yes with Cambridge and Oxford? Yeah, that's the idea for demonstration interviews, right? That's why they're called demonstration interviews. They're supposed to be helpful, I think. I think I'm going to do, well, maybe not a demonstration interview, but there's a bonus episode of the MAT Livestream coming up after the MAT has happened and everyone has moved on to other things in their lives. After that, when the dust settles, we've got a bonus episode about interview questions. We'll talk about some interviews. Right, good, okay. What's the biggest mistake people make in their personal statements for maths? People don't really make mistakes in personal statements. In fact, also, we're pretty lucky, right? Our applicants don't generally, like, it's not the case that we can sort out people who are doing things perfectly from people who have messed up. Like, it's not the case that they've messed up. We're lucky that we've got applicants who are good at maths. And let's do a reality check quickly, because I can zoom in and out and show you bits of maths, but maybe the pep talk you need is that if you're doing math questions and you're solving things and you're thinking hard about the maths that you know, then I think you're going to do well at university maths. I think you're going to like it. Whether that's at Oxford or not, I sort of think that doing this sort of thing and practicing solving tricky maths problems and just being stuck on things is just good for you, getting ready for university and maybe even life afterwards. Oxford's oversubscribed. We've got loads of applicants and not as many spaces as we've got applicants, which means that there's this huge admissions process where we try and choose the people who have the potential to succeed on the course. If it doesn't work out, if you don't end up at Oxford, you shouldn't take that personally. Loads of great mathematicians. Right. Yeah, right, okay, good. Right, that was my serious talk to the camera. Should we zoom in on another question? Should we do another one? Oh, I think there was a vote a while ago. It's 10 to 7, so I don't quite know how to structure this. Question 4 was doing quite well in the vote. It's a bit too votey now to upset things, but it's just some sort of classic stuff. Classic moving things around. That's me looking at the vote. I sort of saw someone vote for question 4 there, I think. Maybe it was question 2, which bar moved. I don't know why this hasn't popped in. I'm having a bit of a problem with my whiteboard today. That maybe it's because I've put so many questions in. Usually when I zoom in, it increases the clarity. This one's really fuzzy, right? Should we do 10 minutes of really fuzzy question? Let's have at least 5 minutes of really... There we go. I just had to look closer at it, right? If in doubt, if you're reading and it's all fuzzy, then try going right up close to your face. Going away. That seems to work in Miro anyway. Love Miro. Miro free. Thank you, Miro, for being free. Okay, here's a parabola. Oh, I love the parabola. It's not the focus of the parabola. It doesn't say focus, but I was trying to find out about Newton. There's a thing called a focus of a parabola. Lots of properties of parabolas. Isaac Newton is very keen on parabolas. Lots of properties come back to understanding what the focus of a parabola is. It's not on A level, it's not on the MAT syllabus, it's not something that you need to know, but once you've done a few MAT questions about parabolas, you tend to notice that there's this kind of magic value of 1/4 or something, or there's kind of point somewhere on the y-axis for this y equals x squared parabola that seems to come up quite a lot. I wonder if it's a focus thing. Anyway, never mind. Speaking of focus, I should try and do the question rather than thinking about Isaac Newton. Right, find the equation of L that goes through that point and is normal to C. That's something that we can just do using A-level maths. We know the gradient, so we know the gradient of the normal. Then we know a point that the normal goes through will be good. And we're asked, when does this line go through P? And I suppose what I'm expecting, where is P? We know where P is, it's at 0, 1. I'm going to label it like this to make it more obvious to me. I mean, it's also on the picture, isn't it? What am I expecting? Probably somewhere over here, maybe? Oh, I guess down here. I'll try to draw a tangent and the normal, and then maybe somewhere over here. Oh, I kind of want to do it now. I guess to find out if it goes through P, we just need to know if at x equals 0, y equals 1. I guess that is a special case then. Is A, are we told that A is positive? No. So A could be 0. Ugh. So actually I'm correcting this. There's kind of a special case if A equals 0. That line will be vertical. Vertical lines are scary to me because They don't have an expression of the form y is mx plus c if it's a vertical line, and that's my favourite form for the equation of a line. So there you go. We should plug in one. Did you get a quadratic? Good. Okay. Good. Am I sponsored? No, kind of almost the opposite, except it is free software. I think if I try to approach them for money, for a sponsorship right from Miro, I think probably they would suggest that I pay for this product that I've been using for the last 5 or 6 years. Right. Most disastrous sponsorship meeting ever. Right, I've left giving them. Oh no. Right. Okay. Find the length of QP as squared as a function of a. Find the distance. So this is separate. This is not to do with L. This is just a kind of A-level maths fact. But we've got several of them stacked together, haven't we? We've got does this line go through this point? We've got find this line, given some properties. We've got find the distance, find the values of A for which the distance is smallest. And then, oh my goodness, separate, I think. This just looks really different. Anytime a math question introduces quite a bit more text, part of me relaxes because it's a sign that we're onto, we might get some rewards for understanding text, and I can read, so maybe reading this new text will cause me to get some marks, right? I'm gonna have to think as well, probably, but we can work on that for me. Find a point R in the plane but not on the curve, such that the distance from R to Q is smallest for a unique value of A. So the value of A controls where the point Q is, and we're supposed to justify our answer, but I think I'm going to be quite chill about this. So where should we put R? Apparently it's not unique for P. There are other values of A. It'd be funny if it's the same values of A in part 2 and part 4. I kind of want to do this now. I've got 3 minutes on the stream. Confusion for 5. Oh yeah, I'm sponsored by Oxford. Thank you for the reminder. I'm sponsored by the Oxford in the sense that I work here, and it's on the screen, so I haven't forgotten. I'm in Oxford right now. Good, I'm having fun. Is it the same values of A? Oh, we should maybe work this out. I kind of want to do it. I've only got a couple of minutes. Let's just see. I can look at the solutions. And also, I am going to look at the solutions because Kay says that the solution for the last part is confusing. So I know I say not to do this, but hey, solutions. Where are we? We're over here. So part I, let's zoom in this. Zoom this in a little bit. There we go. Can we just go where? There we go. Solutions. Solutions are available on the MAT website, and if you're playing along year by year, they're helpfully placed in the table of worksheets for MAT Livestream things on that live page. Okay, different shape gradient, normal, line, good, values. Oh, this includes the A equals 0 case, which they're worried about up here. I didn't think of that in time, but I could go back and add it in. I think this, and then part 2, these values are, you get a quadratic and then you separately get A equals 0, that case where the normal is vertical. It's always a bit tricky to think of that, isn't it? So in this case, it is the same values of A. Oh, brilliant. Okay, that is good. It's a shame the question doesn't ask you to think about that at all. I think that's the cool thing that's going on. You have these 2 different calculations that give you the same numbers. Okay. It even says in the solutions, note that these were the same, but not for any reason. Unless it's square brackets, I think it's a sort of aside. So what's this talking about? We need to find a point R, not on C, such that RQ is smallest for a unique value of A. Yes, that is the question. So this thing K says. If you put R at the origin, that's on the curve C. Sorry, they say not on C in the question down here. Not on C. I'm sorry. It does go through the origin. But nice idea, close enough. Their suggestion is to put the point R a bit below that, so that the origin is the closest point. Out of all of the points on C, the origin is the closest point on C. No other point in the upper half plane, and hence no other point in C. This is a very specific argument for this point, so I can do this argument a bit slow motion if you like. In general, well, no, don't say in general. So the argument that they're making is that if you put r down here, then the distance to this point of C is exactly 1, and the distance to any other point of C will be more than 1, because by Pythagoras you would do the sum of the squares of these things and then the square root. But the sum of the squares of these things is huge, partly because this thing is bigger than 1. So they're saying anything in the upper half plane, which is above the x-axis, anything above the x-axis, the y displacement is greater than 1, which means that the sum of the squares is greater than 1, which means the distance to that point is greater than 1. And sort of everything in the upper half plane, oh, don't shade the whole thing, that's a mess. Everything in the upper half plane, up here and above, is really far away from the point R. So that's a kind of quite neat argument. The mark scheme wrote it up as if it's kind of obvious, but I don't think it's that obvious. In fact, I think you could put R anywhere outside, but it's a bit more awkward to talk about how the closest point is this one here, and it curves away from R, so that's unique because that's the minimum. You can't get that. No. The description at the top there uses some clever words, but doesn't tell me why. I mean, if I put R inside, then Cartesian space is a metric space, still true, and does satisfy the triangle inequality. But I mean, it's no longer true because there's 3 points where the distance is minimized. I suppose I should put it at P, where the whole point of the previous part is to put it at P. Maybe if that's in context, if you're talking about a specific situation where you have a triangle in mind, then maybe that's a sensible thing to say. But if that's your whole answer, then it's too strong, too general. Yeah, Anonymous wanted to put R directly below the origin as well. Yes, and then you get arguments like this. Think about growing circles from P. The first time the circle intersects the parabola, it must be tangent to the normal goes through P. If you think about growing circles, then you realise that this question is actually quite similar to a different MAT question that we've looked at before, to do with balancing circles of different sizes at different heights on a given parabola. We had a circle of radius A and a circle of radius R and centre A going up and down, and we were interested in how many solutions, how many intersections there might be. These questions are quite similar to each other. If you think about, well, let's think about the relationship between the distance from R to the curve C. Maybe rephrase that as the minimum distance between any point of C and the fixed point R. There's some relationship between that and the largest radius of a circle that doesn't intersect C that's centered at R. Geometry-ish. Right, good, okay. Q doesn't actually have to be 0, 0. All of the ones that people are talking about in chat, it's the case that they're picking points down here somewhere for R, and then Q is the smallest. Q is the smallest when it's the distance RQ is minimized when Q is at the origin for their choices of R. On the right, I'm trying to demonstrate that if you put R somewhere over here, you still have the same property, and the distance is not minimized when Q is at the origin, but it's much harder to think about and it's much harder to explain. So I think that's not a popular choice. What about when the distance of R is less than 1? When it's squared, it's smaller. What does distance of R mean? Or distance of R from the curve C, maybe? If you put this really close, like down here, maybe still on the y-axis for Rosie. Right, yeah, if it's less than, if you go a bit closer, everything's still fine. So if you are down here at like -1/2, then the same argument holds. To get to somewhere else on the curve C, you'd have to go more than 1/2 this way. So you'd have, I don't know what these are, distances A and B. A is more than 1/2. A squared plus B squared square rooted is more than the square root of 1/2 squared. Because B squared is positive, is more than. It's actually equal to 1/2, isn't it? So this distance root a squared plus b squared is greater than root 1/2 squared. I suppose greater than or equal to if b is 0. B squared is a positive number. I've made a mess of that. I'm going to try one more time, even though I'm over time. So there's this argument in the solutions where they're talking about why the distance to just anything in the upper half plane, so any point in the upper half plane, they're not really using any facts about parabolas, they're just talking about the distance to anything in the upper half plane. And they're thinking about Pythagoras, I think, where they're thinking there's some displacement this way and some displacement that way, A and B. And because this is in the lower half plane and this is somewhere in the upper half plane, if this is 1/2 over here or something, or 1/4 or 1 or 17 or whatever, whatever you've picked, so maybe 1 or maybe a number less than 1, then square root of a squared plus b squared, the relevant distance, that dotted line, is greater than or equal to the square root of a squared, which is greater than or equal to 1/2 squared, which is 1/2. So this step here is because a is greater than or equal to 1/2, because you have to get all the way into the other half plane. And this step here is because going sideways just makes you further away. B squared is greater than or equal to 0. So everything in that upper half plane is far away. For a kind of geometry reason that, well, if this is the seaside and this is the line of the front of the water, where the water meets the beach, then to get into the water, I could run straight to the water, or I could go aiming for somewhere else and get really, really into the sea, but that's further away. The kind of closest point would be this bit here. Anyway, so geometry, and also for an algebra reason that you can write down using Pythagoras this fact and then use some inequalities on it. Good. Can you pick R to be some point inside the curve but near it and far from the origin? Yeah. So the hard question is, which points R is this true for? And if your point is close enough to the curve, then this is fine and you can get away with it. But that is much, much harder to explain and not very obvious. Good. Okay. It's not just any point below the graph. You can do this for yourself if you repeat the question, but moving P somewhere else, closer to the origin. Then the maths is not much harder. You can find, you only need to repeat parts 3 and 4. Forget about the lines and the normals. If you move P down, you can repeat the maths, and you'll find that if P is close enough to the curve, then the property in 5 holds. So the obvious thing to do, obvious in some sense, is to put the point outside and underneath, but you can also put it inside and very close. Well done. Anonymous in there, he said, can't we also pick R? And the critical point there, the point where it switches, is, I think, the focus of the parabola. But that is a quest for me to try and learn more obscure facts about parabolas that were popular with Isaac Newton. Right. Good. Okay, I'm going to stop the stream there, I think. Dinner time for me. I will see you next week for another episode where we'll look at 3 more past papers. I think it seems like the right number for this, just going through questions that people want to do. So if you want to have a look at the questions from 2010, 11 and 12, then that's the plan for next week on the show. Do check the MAT Livestream page. We've had to make a change to the date of the session in 2 weeks' time. I'll remind you next week. But the one in 2 weeks' time is actually on Friday instead of Thursday. Sorry for the change. But we will see you in 166 hours for another episode of the Oxford MAT Livestream. Until then, have a nice evening, have a nice weekend, and have a nice week. See you next week. Bye.